All right, just trying to demonstrate Michaelson Morley here. I'm doing it at night because the fringes are fairly faint and it helps quite a bit to see actually the fringes when it's dark. Here you can see there's a cat. Maybe you see? Cat detected. All right. Um, Basically, we have a laser here. It's just a source of light, which I guess is coherent and has some desirable properties. I don't know too much about that. I need to learn more about what would happen if we use different light sources. But basically, this one works for our purposes. Um, the phases are fairly coherent over long distances is kind of the goal. But basically, we have these two mirrors and this beam splitter. The beam splitter is at this sort of 45-degree angle, such that, or 135, let's call it, if you look at the bottom right corner as the origin, such that the beam will reflect when it goes from bottom to top. It'll reflect and go to the left and up. Half of it will reflect and half of it will go through. And then it will reflect off these two mirrors, coming back to that same location in the beam splitter, not interacting with the rest of the light, which is coming in the opposite direction. Half of it will come through in each case, but in each case also some of it will go to the right here. And that will allow us to image some interference, hopefully. So the goal here is to basically see what will look like, I don't know, like an eye with basically concentric circles. We want to see concentric circles, and what those represent are some measure of the difference in phase caused by radial distance from the center of the laser sort of beam here, based on where in the beam splitter it hits. Difference in phase between the beams that are coming from one mirror and the other mirror. So somehow it just works, which is very weird for me here because, oops, let me show it here. I don't know if you can see these fringes. If I move further out, you might see them better. It's a little bigger. I think that's quite visible from the camera. See these fringes? Pretty clear. Not sure what's going on here because if you look closely, you notice there's like a gazillion sort of lasers going on. And if I sort of change the angle like this, actually nothing happens. Like further off, okay, there are the fringes. It's hard to do this with the camera, but okay. Trying to align the vertical direction here of the mirrors because, there's small mistakes. Nothing is changing. However, I'm going to rotate a little bit this cube, which is the beam splitter. Now it's like slightly off. Still works for now. It's kind of hard to be in the right place here, to have something that's blocking. Still seems to kind of work. I have to show it. Still works. Very interesting how often it works. Like how wrong does it need to be to stop working? Well, it still seems to work. Something really strange is going on here. I'm not sure why we get this interference like this. Like I don't know what is interfering with what exactly. But I can show you that if I eliminate some of the source of light, for example, by using something to block one of the two mirrors, so that's what I'm doing here. It's kind of hard to, doesn't want to stay where I want to stay. Okay, that's a problem. Okay. Basically, here I've put some cardboard. It should block the light that's gonna come from the mirror. You can see that there's actually no interference. So we do have some notion that it's only when multiple beams interact that we get interference. But it's not very clear why it behaves the way it does, because as you can see, there's like a gazillion sort of these laser lights. I don't know what's going on. I think my beam splitter is just like kind of screwy, but I do think this is due to interference for that reason, because you can basically turn it into one beam and you'll see there's interference. If we look backwards here, there's a massive pattern here of interference, which is coming from like going behind the laser. This makes sense because this is sort of the other location that the light arrives at. Aside from, you know, the right side, it also goes backwards. You assume it can't go through the laser, but I guess somehow it's managing to get there. Interesting to see how pixelated it is. I don't know if you can tell, but this thing is hella pixelated. This is crazy pixelated. But do seem to have some success here. Can try and see what happens when there is sort of no interference. We looked before, but I can show you again. I'm going to remove sort of our apparatus here. Apologize if this is like the camera looks at random places at sometimes, but it's hard to have one hand like this. Maybe you need like a GoPro. But now we have just like a laser. You can see here, this is just like a laser pointing somewhere. I have a piece of paper here, so here you can see, for example, and these don't seem to be interference fringes. What we're seeing here, this is something else. Like the pattern, I don't know if you can see, but it looks very different, sort of. I'm not sure what it is, but it looks very different. But now I'm sort of moving further away from the laser. I did find something which I thought was interesting, which is, I don't know if you can, if we're gonna observe it, we need to be quite distant. Okay, we can observe it here. I don't know if it's visible, but, and I don't know why the camera keeps showing these weird circles, concentric circles. They're not something I'm seeing with my eyes, but you zoom in here, you may or may not be able to see the fact that as you go outwards from the center of this beam, there's like little wavelets, like visually, like you see little wavelets when I cut it at an angle. So when I don't cut it at an angle, you know, maybe it's still there a little bit. It's hard to tell. But there seem to be these radial, almost wavelets, like there's little circles around the beam. I don't know what's going on there. Maybe this is interference. Maybe this laser has multiple components inside of it, and those are interfering. I really don't know. But it's quite strange that I can just like do this. Oh, you definitely see it. What the heck is going on? I don't know if it's just slicing the laser and finding out that, you know, there's like negative and positive sort of interference going on inside of it, because maybe it becomes decoherent at this length. And if I go close to it, you know, it becomes harder to see, though I still see it here, almost, you know, 1 meter away. But if I go closer, even yet closer, if I'm, you know, maybe a foot away, it doesn't seem to show this stuff. I don't know why decoherence, what decoherence would exactly entail and why it would cause this. Maybe it's due to some notion of the air, when it hits the air, it's dispersing or something. And then that's creating basically new emitters, which are somehow, they have some sort of pattern. But that's quite strange. So, I don't know, interesting observation. I'm going to try and figure more out about this.